Hello there. This time we are going to discuss Article 87, 88, and 89. These three articles all refer to the properties of medians. So the first one is about the mid-segment theorem for a triangle. We learned this particular theorem in elementary geometry, so it's more of a recall, but for today, why don't we focus on proving it and extend it to the lessons that we've got, okay? So, um, it says here that this particular segment, segment MN of triangle ABC, is one of the three mid-segments. And at the same time, MN is half the length of the opposite side of triangle ABC, which is segment BC. So BC is equal to twice MN. So the theorem says that the line joining the midpoints of two sides of a triangle is actually parallel to the third side and is equal to half its length. Let's consider the second part of the theorem later, okay? So, what it says is the fact that point M is a midpoint of segment AB, point N is the midpoint of segment AC, and hence if I connect the 2 points, I have the mid-segment. And this mid-segment is actually half the size of segment BC. What I did is to translate a triangle AMN so that it is on this particular side, this particular theorem, this particular triangle, okay? So, it's so easy to claim that AM is actually, twice of AM is actually AB, and this particular side, AN, is 2 times of that is equal to AC. And I mentioned it here. 2AM is equal to AB, 2AN is equal to AC, and angle A is congruent to itself. And therefore, the two triangles AMN is similar to triangle ABC. And because they are similar, side MN and side BC are related to each other, and thus 2MN is equal to BC, okay? But in addition to that one, using the word homotety, okay, we know that this triangle AMN is homothetic to triangle ABC, and the center of homotety is A, and the constant ratio or the homothetic ratio is actually 1:T, okay? And that's explain why. Another way to prove it is using coordinate geometry. I still will prove it. Some of us prove this in our elementary geometry using coordinate geometry. So what I did was I put point B in the origin, in the x and y axis, and then let's put C here, and let's do that. Okay, I will merge point C to the x-axis, and if that's the case, then definitely point B has coordinates 0, 0. Coordinate xy for point A, and point C is, let's make it z0. That seems to be just right. Okay, let's hide this. Okay, and because of that one, by the midpoint theorem, the coordinates of midpoint M is x over 2, y over 2, while the coordinates of N are x plus y, x plus z rather, over 2, comma, y over 2. Thus, that's easy. But we know that BC is so easy to compute. BC is equal to z, okay? Because it's just in the horizontal line, and therefore z minus 0 is just z. But Mn, you notice they have the same y coordinate that makes this one 0, and the x coordinate is just x plus z over 2 minus x over 2. That leaves us z squared over 4. That leaves us with z, okay? Z over 2 rather. Let me correct that one. So that is z divided by 2. Okay, so thus we know that Mn, let's write it here, thus Mn, 2Mn, just like the 2Mn is equal to 1/2 of BC. Okay, that's the thing that we've got to do. Furthermore, in terms of slopes, since this is the horizontal line, then the slope of BC is equal to, okay, slope of BC is equal to 0. And the slope of Mn is, what's the slope of Mn? The slope of Mn is like change in y. Y2 minus y over 2 is also equal to 0 over whatever is the value of x, but that leaves us with 0. So, since the slope of Mn and the slope of BC are both equal to 0, we now say that thus BC is parallel. BC is parallel to Mn. Mn is parallel to BC. So now we actually prove this one. So not only is it parallel, but it's also half the length of this one. Okay? But to prove the second statement, okay, the line drawn parallel to the side of a triangle through the midpoint of another one passes through the midpoint of the third side. So it's now a different version of it, but it's still this identical to the mid-segment one. So what it does is this. If I construct a line that passes through M and is parallel to segment BC, will it pass through N? And that's the question. So, well, it will definitely, because that's what the theorem is. But to prove this, it's much easier to consider what we learned before, that if you have 3 parallel lines and you have a transversal, say this is the transversal here, let me construct that particular line, construct line, and the color of that line is, okay, let's make that one green. Okay, so this is the transversal line T. So this is line T. Transversal line T is chop, as we all know. Is cut off, is segment BC, AB rather, is a portion of transversal T, and this particular segment is cut into 2 congruent segments, AM and MB, into 2 congruent segments. Then we know that if there is another transversal that will cut here, say this particular segment here, then we know that okay, let me label this one as, okay, wait a minute, PQR. Then we know by this theorem that PQ equals, PQ is equal to QR. There we go. However, we all know, ladies and gentlemen, that this line AC is another transversal of these 3 parallel lines. And it definitely, this particular transversal intersects the 3 lines at points A and and C. And hence, N is a midpoint. So we know that here, AN is equal to NC. Wait a minute. So AN is equal to NC? Wait, so that means that N is truly the midpoint. Thus, N is the midpoint of AC. Segment AC rather. Okay. Oh, so that's what Article 87 is all about. Okay. The next one is Article 88. And it says there that the three medians of a triangle meet in a point, and we call that point G because G is actually the center of gravity, and each median, we'll just consider two medians, okay, is trisected by point G. Well, looking at this particular diagram, okay, we know that segment B prime C prime is the mid segment, and hence it's parallel to segment BC, and also B prime C prime is half the length of segment BC. So because of that, because they are parallel to each other, these two are parallel, and this triangle and that triangle, these two angles here are vertical angles. Therefore, the blue triangle and the yellow triangles are similar to each other. And not only are they similar, they are indeed homothetic. And G is the center of homotheity. And the homothetic ratio is 2:1. And because of that one, since the homothetic ratio is 2:1, then we know that 2BG, 2B prime G prime, 2B prime G is equal to BG, and also C prime G is equal to CG. Thus, we finish it, okay? So that's what theorem 88 and 89 is. So, and G is called the centroid of the triangle. But there are other things that we can discuss. So let us summarize it so far. So here it is. So in this particular diagram, we know that AG is 2/3 of AA prime, median AA prime, and A prime G is 1/3 of median AA prime, or in this, or we can say that A prime G is 1/2 of AG. This is actually half of this particular segment. That is also true for median BB prime. This is median BB prime, okay, is cut by G or trisected by G. Thus, GB prime is half of BG, okay? Or you can think of it as 1/2 or 2/3. Sometimes these properties are called 1/3, 2/3 theorem in the triangle, okay? And for the mid segments, we know that, okay, the three mid segments now are A prime, B prime. That's the first segment. Next is B prime, C prime. And last but not the least is C prime, A prime. And those are the three mid segments. Furthermore, these three mid segments are parallel to the opposite sides, meaning this is parallel to this and is also half. These two are parallel to each other, and also A prime B prime is B prime C prime is half of BC. But we can go beyond that one. We can think of it in terms of triangles. The three yellow triangles are actually congruent to each other. Okay, let me prove one of them. Okay, this is half the length of this, and therefore this segment A prime C prime is congruent to segment AB prime or B prime C. Okay, this segment is also congruent to this or congruent to this. And finally, this is congruent to this particular segment or this particular segment. Therefore, by SSS principle, these three yellow triangles are congruent to each other and they have the same orientation. What I meant by the second one, the green triangle, which is actually this one, is also congruent to it, but it is rotated around G. Okay, so this is the reverse version of the rotated version of the yellow triangles. But let's hide the yellow triangles and the green triangles. But this time, let's focus on the parallelograms. There are three parallelograms here. The first one is the red one, okay, with using vertex A, because this is parallel and is half of it or is equal to AC prime. And these two are parallel, therefore this is a parallelogram. The next one is making use of vertex B. So the blue quadrilateral is a parallelogram. Last but not the least is the brown quadrilateral is also a parallelogram. So that is those are the properties of medians that we all learned in elementary geometry. That's kind of cool. Okay, and that's all. See you in the next discussion of the next article. Thank you very much. Bye-bye.